Good morning. So we continue the lesson. So we were talking about equation systems, but we also want to understand that how we can solve some word problems using system of equations. Yes. So let us start by giving some examples. Okay. So the first problem that I want to solve is a simple problem here. Uh, uh, so here we want to, for example, find two numbers whose sum is 53 and the difference is 19. Yes, so you will also sometimes get these kinds of questions. You are supposed to set up your system. So far, the system was given to you and you were supposed to solve the given system. But sometimes, as we had for the one uh, equation in one unknown, you need to read the question, set up the equation yourself, and solve it. So here is also the same. For example, the question is asking, find two numbers whose sum is equal to, for example, 53, and the difference is what? The difference is 19. So this is actually an E-level question, but let us start with a very simple one. So you see, this is a word problem. The sum of two numbers is 53 and their difference is 19. Find the numbers. So what should I do here? Because there are two unknown numbers involved here, I would say let x and y be those numbers. Something like this sentence is necessary when you start. And then you start translating what is given to you. You see that the sum is supposed to be 53. So what does it mean? The numbers that I am looking for, one of them I called x, the other one I called y, and the problem is telling me that the sum is 53. So what should I understand? I understand that if I add these two numbers, it is supposed to be 53, and the difference is 19. Here you can write y minus x or x minus y. If you write x minus y, you are assuming x is the bigger number. If you write y minus x is 19, you're assuming that y is bigger. So it doesn't matter here. So let me write x minus y is equal to 19. So I have two unknowns and I have two pieces of information given in the problem. So in principle, I can set up this system and solve. This system is extremely simple. I can use addition method here. For example, I add them. X and x becomes 2x. Y and y are cancelled. 19 plus 53 is 70. And then I am looking for x, so I divide by 2. It becomes 36. And x is 36. I put it back in one of these equations. For example, the first one, 36 plus y is 53, and then y becomes 53 minus 36, which is how much? 17. Yes, so this is 70. So you, as the answer, you say that the numbers are 36 and 70. That is, you have to write. So something like this, but this was the extremely simple one. Yes, we can go to a little bit better problems, okay? The units digit of a two-digit number. By the way, when I say, for example, 53, I don't know, 123, the number appearing on the rightmost place is called the units digit. Okay, for example, the second number is called the tens digit. Yes, the next one is the hundredths digit or something like that. Because it's good to know about these numbers. But anyway, here when they say the units digit, it means the rightmost digit in a number. The units digit of a two-digit number is one less than twice the tens digit. Okay, exactly. You have to be able to uh, put it properly. So it tells you that. Let us read it again. The units digit of a two-digit number is one less than twice the tens digit. The sum of the digits is 8. Find the number. Okay? So I have a two-digit number. So in a two-digit number, I don't know. For example, let me write my two-digit number as A and B. A is missing, B is also missing. Because I am supposed to find the number. So if I want to find a two-digit number, I need to know A, I need to know B. Okay, so let me show the question here. So the units digit means which one? Means which one? On the board, A, B. The units digit means which one? B. The units digit of a two-digit number is one less than twice the tens digit. So how can you translate this? The units digit means B is 1 unit less than twice the tens digit. So it means that if I take the tens digit and multiply it by 2 and subtract 1 from it, it becomes the units digit. So that is the translation of the first sentence. And the second one is very clear. The sum of the digits is 8. Find the number. So the sum of the digits is 8 means what? A plus B is 8. And then I want to find my number. So this is my system. So that's the same story. So you just read the problem in words and to set up equations yourself, and then you can find the solution as before. So which method is better for this one? Substitution is better because B is expressed in terms of A. So I go to the second equation, I write A, but instead of B, I put 2A minus 1 is equal to 8. 2A plus A is 3A. I move 1 to the other side, it becomes 9. I divide by 3, so it becomes 3. So A is 3. When A is 3, B is 2 times 3 minus 1, which is 5. Okay, so B is 5. So what is that number then? So the answer, the number is AB, but A is 3, B is 5, so the number is what? 35. Yes? So that's also simple. Okay, so let us solve another one so that you get a feeling what is going on. For example, let us see what is coming next. Let us solve this problem, for example. Let us read it. A motel rents double rooms at this price, $100 per day, and single rooms at $75 per day. If 23 rooms were rented one day for a total of $2,100, how many rooms of each kind were rented? Okay, I don't want to start solving it. I want you to take a paper and try to solve the problem yourself first. A motel rents double rooms at this price, $100, and single rooms at this price per day. 23 rooms were rented, and the total money that the motel got from the customers is $2,100. How many rooms of each kind were rented? Okay, so I want to wait for you. Okay, could you solve it? No? I wait a little bit more because it's not hard. Okay, so if you solve that one, I want you to think, and then I will solve both of them together for you. This is also a good problem, I think. Yes. So yeah, think about these two problems, and then we solve them together. Okay. So let us see. Question the motel one. So I have written the information here. So the double room price is 100 per day, single room price is 75 per day, and the total number of rooms rented is 23, and the total rent is $2,100. Okay, and then what is wanted? I recommend you to go directly to the last part of the question immediately. How many rooms of each kind were rented? So that is what you don't know. So you go here and, I don't know, start a sentence like this. Let, for example, D be the number of double rooms rented uh, rented, and for example S be be the number, S be the number of single rooms rented. So what motivates me to write this? Because I read the last part of the question. The question is asking how many double rooms are rented, how many single rooms are rented. That is my target to find. So I give them name. In order to not to forget, it is better to call them D and S. And then I want to find D, and then I want to find S. Something I immediately understand. The total number of rooms rented is 23. So I know that S plus D is what? Is 23. On the other hand, I know how much money has been paid, $2,100 in total. So how do you do that? I would say that I have S number of single rooms, and S, the price of the single room is $75. So I have to, how much money people have paid for single rooms in total? $75 times S. Yes, because S is the number of single rooms rented. Every room costs $75. So the money that motel gets from the customers based on renting the single rooms is 75 times the number of single rooms. And for the same reason, how much money the motel got from the customers based on the renting double rooms is, each double room is $100 per day. So 100 times D is the money that motel gets from that. And in total means the sum of them is 2100. Yes? And then you have to solve the system. If you solve this system, you can find S, you can find D, and then that's the answer that we want to provide. So that's a very simple question, but the numbers are a little bit big. You can, if the calculator is allowed, so no problems. If the calculator is not allowed, you can still do something reasonable. I mean, for example, can you see that I can simplify this equation? For example, I can divide everything by 5, yes? But I can also divide everything by 25, yes? So if I divide everything by 25 here, so the problem becomes simpler. Because if I divide this by 25, it becomes 3 times S. If I divide this by 25, it is just 4D. And if I this by 25, 8 and 4 is 12, yes? No. So 25 as 20, so let me see. 100 is 4 times, and then 2000 is 20 times 4 times, so 80, 84, yes? Yes. So let me double check. I divide everything by 25, so 200 divided by 25, yes, it's 84. I don't know if that was your problem. In principle, you have access to calculator if the numbers are big, so you can immediately start the addition method. And if, of course, you have access to calculator, multiplying this by a big number is not a problem. But anyway, because I realized that all of these numbers are divisible by 25, instead of working with big numbers, I prefer to divide everything. And then instead of solving this system, I write a new system, which is simpler in numbers, 3s, and then 4d is equal to 84. And then I think it is better to use addition method here. To addition method, I multiply the first one by minus 3, for example. It becomes minus 3s minus 3d is minus 3 times here is minus 69. And then I have 3s plus 4d is equal to 84. And then I add them. 4d minus 3d is just simply d. 84 minus 69 is 15. Yes. So the number of double rooms rented is 15. And in total, it is 23. So S becomes 23 minus 15. So S becomes 8. So you need to write this as the answer. So 15 double rooms and 8 single rooms. Yes, so this is the number that you have to provide here. Any questions? So if I mean the only problem that you're not probably comfortable with is dividing by 25. So you don't need to do that. For example, you can start addition method from the beginning by multiplying this by minus 75. Minus 75s and 75s will be gone. Minus 75d plus 100d becomes 25d. And then, of course, I will give you access to calculator. You multiply this number by minus 75 and then add to 2100. So that's not a big problem. But then I realized that every number is divisible by 25. So I did division first so that I can solve a system with the smaller numbers. But that's it. Okay, but what about the next question? The next question is more interesting, yes? One solution contains 30% alcohol and a second solution contains 70% alcohol. How many liters of each solution should be mixed to make 10 liters containing 40% alcohol? Yes, so that's a better question because for this question, I don't think you face a big problem, yes? Again, if you don't listen to me, Derman, you will be confused. When I read these questions, first of all, I read them 2 times. Listen to me, please. And then how many liters of each solution? Okay, so this is the question. So I go back here. I have solution number 1. It contains how many liters of alcohol? 30% alcohol, yes? And solution number 2 contains 70% alcohol. I want to know how many liters of this one and how many liters of this one. So let me write L1 for the number of liters from solution 1 and L2 from the number of liters of solution 2. I want to mix these solutions in a way that in total, if you read the last part, to make 10 liters containing 40% alcohol. Okay, so 10 liters in total. So it means that L1, the number of liters I use as 1, the number of liters I use as 2 should in total be 10 liters. Yes, this is one easy one. But the next one is that the new solution, I want to have it 40% alcohol, including 40% alcohol. How can I bring this into the problem? How should I do that? No, S1 is nothing. X1 is a name. L1 is the number of liters that I can use. I have to use solution number 1. L2 is the number of liters that I have to use solution number 2 to reach my goal. What is my goal? My goal is that in total I want to have 10 liters. So it means L1 plus L2 is 10 liters. But I want the new 10 liter of solution contain 40% alcohol. So the first one is easy because I know that L1 is, I choose L1 liters from solution 1, L2 liters from solution 2. So in total it should be 10 liters. But how, in which proportion I should mix these solutions so that the final solution contains 40% alcohol?
L1 times S1 plus L.
There is no S1. S1 is the name. S1, forget about S1. Solution 1. Solution 2. Yes? Instead of writing all those sentences, I am writing solution number 1 contains this one. So what is the meaning S1 is? So no. How is that possible? No, if I have L1 liters of the first solution, how much alcohol I have? The first solution contains 30% alcohol. If I take 1 cc, do I have 1 liter alcohol? No. Whatever I take from solution 1, it doesn't matter, 10 liters, millions of liters, 1 cc, it contains 30% alcohol. That's the meaning. It means the amount of solution 1 you take, is it big or small, it doesn't matter. 30% of that amount of solution 1 includes alcohol. Yes? So now how many of them how much I am taking? I am taking L1 liters. In this L1 liters, how many alcohol you can find? 30% of L1. Yes? So 30%, which means what? 30% means 30% of L1 is alcohol. Yes? That's the meaning. This is when I take L1 liter from solution 1, the amount of alcohol that I have in my choice is this amount, is this liter, is these many liters, yes? And how many alcohols I will have if I choose L2 liters from solution 2? The alcohol that I will have will be what? L2 multiplied by 70%. Yes? So, if I choose L1 liter from solution 1, L2 liters from solution 2, the amount of alcohol that I have is the sum of these two. Yes? Yes or no? Okay. But I want this to be 40% of the final solution. Yes? What is the volume of the final solution? 10 liters. I want to have 40% of that 10 liter be alcohol. So it means that this should be equal to 40% of the final solution. The final solution is 10 liters. Yes? So that is the second equation that you have to add. Okay, let me just repeat again. I am assuming that I take L1 liters from solution 1, L2 liters from solution 2. I want to have 10 liters at the end. So it means that the sum of these two numbers should be 10. This is extremely simple. Okay, just keep it like this. The second problem is that I want the final solution contains 40% alcohol. Yes? 40% of 10 is this number. If I ask you how much is 40% of 10, you write 40 over 100 multiplied by 10. So this is the amount of alcohol that I expect be present in my final solution. But this alcohol should come from these alcohols in these two solutions, yes? So if I take L1 liter, how many alcohols I am taking with me from solution 1? 30% of L1. 30% of L1 is this number. And if I take L2 liters of solution 2, how many alcohols I take with me? 70% of that number. So when I take L1 liters from this one, L2 liters from this one, in total, how many liters of alcohol I took with me? The sum of these two. Yes? This is supposed to be the liter of alcohols in my final solution. But the liter of alcohol in my final solution is 40% of 10 liters. So the sum of these should be this. Yes or no? Okay. So what I will do, first of all, because this is a bad number, I multiply everything by 100, so 100s are gone. And then you see that 30, 70, 40 are all divisible by 10. So I divide by 10 everything. So it becomes 3L1 plus 7L2. I divide this by 10, this is 400. When I divide it by 10, it becomes 40. And this is the second equation. Yes? And now I solve the system. So I write the system here and solve it. So I will write a system L1 plus L2. It should be 10 liters in total. And I realize because of the second constraint, I have to have 3L1, 7L2 is 40. Yes? Yes? Okay, so then you solve the system. Which method is suitable? For example, let me multiply this by minus 3. So it becomes minus 3L1 minus 3L2 is minus 30. And then I have 3L1 plus 7L2 is equal to 40. And I use addition method. So this one and that one are gone. This becomes 4L2. And this becomes what? 10. So L2 is 10 over 4, which is 2,5 liters. So let me write liters, yes. And if L2 is this one, I put it there. So L1 becomes 10 minus 2,5, which is 7,5 liters. So I have to take 2,5 liters of the second solution and 7.5 liters from the first solution. Is that right? So that was a better problem. So you see some of these problems. I didn't give any example of those type of problems. This is why I wanted to give you a flavor of how it goes. So these 4 examples we solved, I think, is enough. It's not a very complicated problem. Any questions here? So the next part that is left is the last part, is discussing about the number of solutions of a system of this type, you know, a linear system. So A, B, C are numbers, A prime, B prime, C prime are numbers. So I want to understand it from geometrical point of view. For example, let me write, to motivate you, let me write a system x minus y equals to 3, and then I would write 2x minus 2y is equal to 4. Let me write it 5. Okay, and I give you this, and I ask you to solve the system. Okay, so if I give you this system to solve, this is extremely simple, but my point is something different. If you want to solve this, which method, for example, you use? You use method of addition, you multiply this by minus 2, and then you see something strange happens. So if I multiply this by minus 2, it becomes minus 2x plus 2y equals to minus 6. And then I have 2x minus 2y is equal to 5. And then when I want to use addition method, you see what happens. 2x and 2x are gone, but unfortunately 2y and 2y are also gone. And on the left hand side I will have 0. On the right hand side, when I add them, it becomes -1, which is nonsense. Okay, so it doesn't mean that the problem is wrong, because I told you that. So that is one thing that happens. Okay, so how can you interpret this result? So I haven't done something wrong. I am using the rule of addition. I multiply this by -2. My goal was to get rid of this x variable, but it was designed in a way that when I wanted to get rid of the x variable, the y variable is also got. We get rid of that one as well. But then I get a very bad looking result that 0 is equal to -1. So what is the interpretation of such a thing? The interpretation is that there are no solutions. Okay, so it means that if you insist to find a simultaneous solution to both of them, then you have to accept 0 is equal to -1. And if you are not insane, you cannot accept that 0 is equal to -1, so it means that there are no solutions. Because the existence of solution gives rise to this contradiction. So that is what I am telling you. So don't think that's a wrong problem. If this happens, what you write as the answer, you write that the system does not have any solutions. This is the answer. But let me give you another scenario. I change this a little bit. So here I write x minus y equals to 3, 2x minus 2y is equal to 6. And I ask you to solve this. And then you use the same method again. You multiply this by -2, so it becomes minus 2x plus 2y is equal to -6. And then you have 2x minus 2y equals to 6 because you want to use the addition method. And then when you add something strange happens again because these are gone. But unfortunately, the second one also gone, so it becomes 0 equals to. When you add them, that's also 0. So this time it is not contradiction, because 0 equals to 0 is a true statement. That was a wrong statement. But here, this is the true statement. So what is the interpretation here then? Again, this doesn't mean the problem is wrong. The interpretation is different. So what should I write here? The problem is there are infinitely many solutions. In other words, the second equation is redundant. Do you know what is the meaning of redundant? Yes? Yes, so it means that it is unnecessary. It is not an extra piece of information. And then you can immediately see that. Because of course, if x minus y is equal to 3, 2 times x minus 2y is definitely 6, because if you multiply that, it becomes 6. So even though apparently I have given you 2 pieces of information, but I was cheating on you because these 2 pieces of information are exactly identical. If x minus y is equal to 3, of course 2x minus 2y is equal to 6. So I'm not providing a new piece of information. So I have only one piece of information, and it means that these 2 equations can be summarized into one equation. So in principle, I have 2 unknown, but I have one constraint, so 1 degree of freedom is left, and that is the reason there are infinitely many solutions. Okay? So far we solved a lot of systems and we found one answer to them, but there are 2 other alternatives. Might be I give you a system. When you want to solve it, you arrive at a contradiction. This means there are no solutions. But sometimes you start solving them, both of the variables are gone, but you don't get a contradiction. You get something which is true. Then it means how many answers are there? Infinitely many answers. This might be a little bit weird, But if you go to geometry, it becomes very natural. When I have a system like this, if I ask GeoGebra to draw the graph of this one, what do you expect GeoGebra gives? Yes? A straight line. The second one is also a straight line. When you want to solve the system, what is the meaning of solving a system geometrically? We had something, yes? No, for example, when I ask GeoGebra to solve this graphically, what do? I ask GeoGebra to draw the graph of this and the graph of this, and then where should I look for? The intersection. But you all just told me that this is a line, that's also a line. So if I have two lines, how many possibilities I have? If I have two lines on the plane of the whiteboard is what? Either they are intersecting, so it means how many intersection points you get? One. This is one of those types. This is the type that we solved so far. All the equations that I gave you are this type. But there are other alternatives. One alternative is what? Is that two lines are parallel. Okay, that's not a good representation of parallel. Okay, if two lines are parallel, where is the intersection point? There are no intersection point, and that is happening. Okay, so the system doesn't have any solution. How do I know these lines are parallel? Do you remember? I need to find the k value. For finding the k value, I move x to the other side, and then I isolate y by dividing by -1, so it becomes x minus 3. So if I ask you what is the k value is 1. What is the k value of the second one? So I will do the same thing. So minus 2y, I move 2x to the other side, and then I have plus 5. I divide by -2, this becomes what? X. This becomes minus 2 comma 5. So what is the k value of this one? Again, 1. So the k values are the same, but the m values are not the same. Yes? If the k values are the same, but the m values are not the same, it means I have two lines that are parallel. And that is exactly, if I have two parallel lines, there are no intersection points. If there is no intersection point, there is no solution. Yes? And then what is the other alternative? Which of course it is very hard to draw, but hopefully you can imagine. So it happens that, sometimes it happens that I have one line, another line is exactly lying on the first line, but I cannot draw it, but I try, for example, by drawing it a different color, okay? So let us imagine this. How many intersection points you find between the black one and the blue one? Infinitely many, because every point is on both of them, okay? And this is happening here. If this happens, it means that the corresponding lines lie on top of each other. Okay? So let us check. If I want to do this, I go here, I find the k and m values by moving x to the other side and dividing by minus sign. By minus sign, I will get x minus 3. And if I do the same thing here, I move 2x to the right, it becomes minus 2x plus 6. I divide by minus 2, it becomes x minus 3. So you see the k values are both equal to 1. And by the way, they are exactly the same lines, and the m values are also the same. So this is very important to understand from geometrical point of view. If I have these type of systems, even though most of the time we solved all the problems and find one solution, but that is not always true. Sometimes we do not have any solutions. If both of them are gone and I get a wrong statement, that is the interpretation. Sometimes both of my unknowns are eliminated, but I do not get a wrong statement, I get a true statement. The interpretation is that there are infinitely many solutions. So this is the idea that you need to understand. From an algebraic point of view, you solve and you know how to interpret, but you also need to have a good understanding from geometrical point of view, because every equation represents a line, and I have three possibilities for two lines. Either they intersect at one single point, or they are parallel, or they lie on top of each other. In this case, one solution, no solutions, infinitely many solutions. Yes? Yeah. What? There is no two solutions because I have two lines. Be careful. That is the interesting thing. You cannot write a system of this type with two solutions. If you respect to write exactly what I told, of course, if you change x to x squared or something, yes. But that interpretation is only for the case that equations are representing lines, straight lines. I mean. Yes? So that is very interesting. So you cannot write a system like this with exactly two solutions. So either there are no solutions, or one solution, or suddenly infinitely many solutions. There are nothing in between. That's a very important characteristic of these linear systems. Okay? But this is the idea. This is not the type of problem that you might face. But for example, this is a harder level question that we want to solve now. So I give you, for example, a system, but I put some parameters in it. For example, let us write nx plus y equals to 7, and then you have so for example, you have x plus y equals to 2. Okay, I give you a system. I don't ask you to solve it, but I ask you, for example, for what value of n the system has no solutions. Okay, so this type of questions you need to understand. So you see, I gave you a system, but I don't ask you to solve and find an x. I am telling you, find n in a way that when you replace n with the number that you find, the system does not have any solutions. Okay, so how should I solve this problem? We just learned that if there is no solutions, the lines should be parallel and not overlapping. So it means that I need to find the k value from this line by isolating y. I also need to isolate y here. And read the k value from this one. So k value, let us call it k number 1 for the first equation. It's minus n. From here, k number 2 is minus 1. Yes? But for what value of n the system has no solutions? If the system is supposed to have no solutions, it means that the line should be parallel. When it means that, you remember the line should be parallel, it happens if k1 is equal to k2. So k1 is minus n1, k2 is minus 1, they have to be equal. So then it means that n should be 1. Okay? But I have to be careful because here the k values are also the same. But I don't want to have this scenario, because if this scenario happens, there are infinitely many solutions. I want to have 0 solutions. So I have to make sure that this is not happening. But do you think it is happening? It is clearly not. Why? Because the m value here is 7, the m value here is 2. So they are automatically not the same. So since the m values are not the same, therefore n equals to 1 is acceptable. Yes, because if n is equal to 1, the lines are parallel, but because m values are not the same, they cannot be on top of each other. They are really parallel. And if they are really parallel, how many solutions are there? 0. And that is exactly what the question is asking. Okay? Now my question, let me change the question. For what value of n the system has one solution? So how do you answer that? No calculation is needed. Whatever is needed is on the board, but interpretation is different. For what value of n the system has no solution, the answer to this part of the problem is n equals to 1 only. If you choose n to be 1, there are no solutions. And by the way, this is not weird. Why? Because if you put 1 instead of x, what happens? If you put 1 instead of n, the first equation reads 7, x plus y 7. The second equation reads x plus y is equal to 2. Of course, this is not possible. It is not possible that x plus y is 7 and at the same time it becomes 2. So it is clear that it should be a contradiction. I gave you a simple example to understand how to do it, because of course I can make the problems a little bit more complicated. We can study a little bit of them on Monday. But anyway, now my question is that for what value or values of n the equation has a unique solution? Yes? Yes, that's exactly. So that's the question. The answer to the second question that I told you just now is n not equal to 1. Because if n is equal to 1, since the n values are not the same, I am facing this scenario. There are no solutions. But if I want them to have one solution, it means that I have to force them to intersect. It means that the k values should not be the same. So it means that the k value, k1, should not be equal to k2. So it means that minus n, which is k1, should not be equal to k2, which is minus 1. So minus n should not be equal to minus 1. So it means that n is not equal to. Yes? So that's the interpretation that you have to understand how to do. Okay, I will solve a little bit more of these problems on Monday, and then this chapter is completely finished. Yes? Any questions? Okay, thank you.